We were discussing about the topic vectors in last class, and we had done exercise 7a in last class. Now in today's class we are going to start with exercise 7b. Now in 7b we are going to discuss how we are going to add the vectors if the vector is in the form of column vectors. And what are column vectors? The vectors which has only one column. Like let's suppose I say that AB is equals to 3 and 4. Now AB is a column vector, it has only one column, right? That is what I meant by column vector. So in question number 1 we need to add all the column vectors. The question says simplify the following, and the first part, it's 2 4 plus 7 5. Now you need to add them together. So adding a column vector is very simple. You need to add the corresponding member. So it will be 2 plus 7 and 4 plus 5. The answer, it will be 7 plus 2 9 and 4 plus 5 is 9. So that is your answer of adding these two vectors. For part B, it's 3 minus 5 plus minus 4 and 1. You need to do it by yourself first. So it will be 3 minus 4, that will be minus 1, and minus 5 plus 1, it will be minus 4. Right? These are the values if you add them together. Next part, C, it's minus 9 minus 2 plus 0 minus 8 plus minus 3 7. You need to do it by yourself first, and for that question I give you approximately 40 seconds. Done? So it will be minus 9 plus 0 minus 9, minus 9 minus 3, it's minus 12, minus 2 minus 8 minus 10, minus 10 plus 7, it's minus 3. So that is the answer of part C. Similarly, if it is given in the form of vectors like question number 2, it says that A is equals to 4 3, B is equals to negative 7 and 2, and C is equals to 1 and minus 5. Determine whether first part, determine whether A plus B is equals to B plus A, first part. Next part is determine whether A plus B plus C is equals to A plus B plus C. So you need to do that question first by yourself, and for that question, for first part only, I give you 1 minute. First part done. Alright class. So first I will write the vectors. It says A plus B, so I will write the vector. A is 4, 3. A plus B is minus 7, 2 is equals to B is minus 7, 2 plus A is 4 and 3. On the left side, 4 minus 3, it's minus 3, and 3 plus 2, it's 5. On the right side, minus 7 plus 4, it's minus 3, and 3 plus 2, 5. So they both are equal. Right? They both are equal. For the next part, A plus B plus C. Now you have the value of A plus B. It's minus 3 and 5. But I'm not going to do it further. You need to try it by yourself first. So let's start. Done? Alright. Now I'm going to start the solution. So A plus B is minus 3 and 5 as we had find out in part A, plus C. The vector C is 1 and negative 5. On the right side we have A, that is 4 and 3, plus B plus C. So B plus C, that means minus 7 plus 1, it's minus 6, and 2 minus 5, it's minus 3. That is my B plus C vector. On the left side, minus 3 plus 1, it's minus 2, and 5 minus 5 is 0. On the right side, I have 4 plus minus 6, it's minus 2, and 3 minus 3 is 0. So they both are equal, and that is our answer. Alright? Now, moving on to the next question. Now, in this question, we have a diagram of a quadrilateral. As you can see on your screens, the quadrilateral shows the diagram shows a quadrilateral PLMN. Now, before I explain this question, first let us clear the concept of how we add the vectors. We have learned how we add the column vectors in the previous question, right? But how we add the vectors if they are given in terms of arrows. Let's suppose you have a vector A and you have a vector B, and you need to add those vectors to find out the resultant of A plus B. Now to add those vectors, we have a method of head to tail. And how we apply this method? First we will make first vector, that is A. It is given in this direction, and whatever the magnitude is, we will make it accordingly. And the end point of vector A, this one, we will make from this point our another vector, vector B, in the same direction as given, right? So that is my vector B, and now I will join from tail to tail and head to head. So that is a resultant of A plus B. That is why it is called head to tail. The resultant vector combined with one tail of the vector and first head of the vector, right? Or you can say that the resultant combines with the first one tail and the second one head, right? The first one was A and the second one was B, so that is a resultant of A plus B, right? Let's take one more example. Let's suppose you have a vector P in this direction and vector Q in this direction. You need to find out the resultant of P plus Q. So first I will draw the vector P in the same direction as given, and where it ends the head I will draw vector Q. This one is vector Q, and the resultant from head to tail rule, that is my resultant P plus Q. So that's how we find the resultant vectors in terms of figures. And there is one small trick to find out the resultant when it is given in terms of alphabets. Let's suppose it is given that AB plus BC. Make sure that you are always drawing this arrowhead on the vectors. So what is the answer of AB plus BC? For that purpose, keep in mind if this letter and this letter is same, so the resultant will be the leftover part, and that is equals to AC. That is your answer. If I say XY plus YQ, so the resultant is XQ. Since these two alphabets are same, so the resultant is the first and the last one. One more example, PQ plus QT is equals to PT, right? So I hope that all of you now have a clear idea how we add the vectors. Now applying those concepts on question number 3. It says the diagram shows the quadrilateral PLMN simplify LM plus MN. So first start with L to M and then from M to N. Now in general I explain this concept in such a way. Let's suppose you are standing at L point, right? You first move to M and then you move from M to N. Now you are standing at N. That means your resultant is from L to N. That is your resultant. If you apply that concept or the technique of alphabets addition of vector, you can see that these two vectors, these two alphabets are same. So the resultant is LN. The both answers can be validated from the diagram and from this alphabetical addition technique as well. Right? Any problem? I hope that it is clear to you. Always suppose that you are standing at the point and you are traveling, so find out your first point and the last point, that is your resultant vector. Part B. PN plus LP. Now, if you observe the question, you will find that N and L are not same, so how we are going to add them together, right? But if I arranged in such a way that first I will write LP and then I will write PN. It does not affect any of the vector, right? We are not changing the direction. We are just placing, like if I say that 2 plus 3, instead of 2 plus 3 I will write 3 plus 2, so it won't affect the answer, right? Both give the value of 5, so that's how if I write LP plus PN, so now I know that since these two letters are same, so it will equal to LN. That is just about the arrangement of the vectors. If you write in this way, it won't affect, right? For part C, LN plus NM plus MP. Now first you need to do that, and that is a short question, so I will give you a time of 30 seconds approx. Done? Alright, so Ln plus Nm, it will be Lm, right? The second and the first letters are same, so the resultant will be the first and the last one. Lm plus Mp, same logic. M and M are same, so the answer will be Lp. That is the resultant of Ln plus Nm plus Mp. Alright, now moving on to the next question. It's question number 4. The question says, simplify the following. First part, 12 minus 6 plus minus 12, 6. Now it will be 0, 0, right? So what is the concept behind those vectors? Basically 12 minus 6 and minus 12 6 are negative vectors. What are negative vectors? I have told you in the first class of vectors, vectors which have same magnitude but opposite direction. So if you see these two vectors, so the numbers are 12 minus 6, 12 6, 12 6, right? Numbers are same but they differ in the direction. That is plus 12, it's minus 12, it's minus 6, and it's plus 6. So the vectors magnitude is same but they are in opposite direction. That is why the sum is 0, 0. Similarly for next part, it's 5, 7. So the negative of this vector will be minus 5, minus 7, and answer it will be 0, 0. Right? For C part, it's xy. Its negative vector will be minus x, minus y, and its answer is 0 and 0. Right? Done? Now, with the same concept we have learned in question number 4. In question number 5, it says 9 plus minus 1 is equals to 0, 0. Now these are two blanks here, right? This number is absent and this number is absent. You need to find out the number by yourself, and for that question I'll give you the time of 1 minute. You need to think of that numbers. What should I add in the 9 to make it 0? Right? I'm repeating my statement. What should be the number I should add in positive 9 to make it 0? So the number should be equals to minus 9, right? So 9 minus 9 equals to 0. Similarly, the second number should be 1. So that 1 minus 1 is equals to 0. So that is the same concept of negative vector in which the resultant is 0. For the next part, it's minus 3 plus 7 0. For the next part, C, P minus Q. Now you have 20 seconds to attempt these two questions. Start. Done? Alright. So the first answer, it will be 3 minus 3 plus 3 0 and minus 7 plus 7 0. Next one, Q minus Q is 0 and P minus P is 0. Right, so that's how you find out the negative vectors. Now before proceeding to further question, we have learned that AB plus BC is equals to AC, right? And the technique was, if these two alphabets are same, then you can write down the first and the last one as a resultant vector, right class? But the question is how you will do if instead of addition the sign is subtraction. Now for subtraction, let's suppose if it's written that OA minus OB, so the final answer, it will be BA. Now what is actually happening in subtraction? For subtraction, the first letter of each vector, they must be same. Like for addition, we say that the second letter of first and the first letter of second, they must be equal. For subtraction, the first letter of both the vectors, they must be same, and the answer will be written as the reverse order, right? First we will write B and then we will write A. Similarly, if you have PQ minus PR, so the answer will be, since P and P is same, so the answer will be RQ, right? You can do that easily. That is the shortest technique to find out the resultant vector, or you can derive it from the positive approach as well. Let's suppose if I say that OA plus AB, can you tell me the answer of this vector? Yes, it's OB, right? Since A and A is same, so the answer is the first and the last one. Now let's arrange this equation. If I write that OA, this positive OB, when I shift it on the left side, it will be negative OB, and when I shift this AB on the right side, it will be minus AB, right? OA minus OB is equals to minus AB. Minus AB is equals to BA, right? According to the concept of negative vectors, minus AB is equals to BA. You can now match your equations so they are same, right? So we can derive the negative approach from the positive working approach, just a bit of arrangement of the working technique, or you can find out directly from the approach that if the first and the first both letters are same, then the resultant will be the reverse order. So these two approaches are very important and you will use them a lot when you are attempting past paper questions or further book questions. These two approaches will be very useful for the upcoming questions. For vector addition, I have told you the method head to tail rule, right? There is one more method. What did I tell you? Let's first revise this one. Let's suppose we have a vector A and we have a vector B. When we need to add them, so we draw the first vector A, and where it ends we draw the next vector B, and after we join head to tail rule method to find out the resultant A plus B. Now that is the first method that I have told you because I think that is very easy to find out the resultant vector, right? Now the second method is, let's suppose you have a vector, these two vectors A, B, and you need to add them. So the next method says draw the vector A and from the same point draw the vector B. Now complete the parallelogram. So that is also a B, right, in parallelogram, and this vector is also a vector. And the diagonal here represents A plus B. You can match the value for both the vectors, their direction is same, right? They both are heading towards northeast side, right? So both the methods are available. This method, the triangular addition, and that is parallelogram approach. Triangle law of vector addition and parallelogram law of vector addition. So in parallelogram law, what was the important point? That both vectors are starting at the same point. And in triangle law, the second vector start from the head of first vector, right? So I give you some examples. You need to find out the addition of vectors by these two methods. So let's suppose question number 1, I say that is a vector A and that is a vector B. That is a vector B, and you need to find out the resultant of A and B. Do it with both of these methods, parallelogram and triangle law, and then I will explain. First, start it by yourself. Your time starts now. Alright class, so first I find out the addition of these two vectors by triangular method. In triangular method I draw the vector A, and where it ends I draw the vector B. Now the triangular method, with the help of head to tail rule, it will be A plus B, right? If I attempt the same questions by parallelogram law of vector addition, I draw the vector A and with the same starting point I draw the vector B. Now complete the parallelogram. It's B and this one is A. The diagonal represents the addition of A plus B, so that is my answer of A plus B, and you can verify that both vectors directions are same. If their direction are same, that means their magnitude are same, because A and B we are taking the same vectors, right? Now I have one more question. We can find out A plus B with the same example of this A and B. How you find A minus B? Now think and then try. How you find A minus B with the same arrows A and B? How you find out the resultant A minus B with the triangular law or the parallelogram law? Try it. Think and then try it. Confused or done? Now recall the concept of negative vector. If I am talking about minus B, keep in mind the magnitude of B remains the same. The minus sign only reverse the direction. Now what does it mean? We have a vector B in this direction, right? That is B. If I talk about negative B, so it will be like this. That is negative B, right? Now the solution, it will be A remains same, it is positive A. Since we need to find out A minus B, now I won't plot this B, I will plot this one because it's a negative B. So that is a negative B, and the resultant is this one, it's A minus B. That's how you find out the negative resultant, just by opposite the sign, opposite the direction of the vector. Negative does not impact on the magnitude, negative only changes its direction. If this vector is a positive way, then what will be the negative way? That will be this vector, and the same concept we had discussed in negative of a vectors, right? So I think that it is quite enough for today class. Inshallah, in next class we are going to continue with the same topic vectors, with the same exercise 7b. Till then, you need to recall all the concepts that we had discussed in exercise 7a and today class, because we are going to implement those concepts in upcoming questions very frequently, especially the addition and the subtraction by alphabetical methods, that AB plus BC. If both letters are same, you can add the vectors. This concept will be very useful, and we are going to use that very frequently in upcoming lectures. So try to memorize all the concepts. See you in next class. Take care and Allah Hafiz.